All right, so welcome everyone. This is our week 4, and so we've got several things to do this week. The video project and watch and review, basic networking lab, and then the regular chapter questions. But so let me just go over. Uh, why is this now? There we go. So weeks 4 through 6 and week 4. So we're also starting the project IP subnetting. So that's a big. I can't believe it's already week 4. I know. Summer moves very fast. It's very fast, right? So I will come back to the project subnetting uh, um, because that's huge, and so we'll have to go into that. Could you elaborate on the outline intro? It's the outline meaning table. Yeah. Uh, Outline intro. Oops, wrong one. Okay, right. So only the outline and introduction are due today, right? So um, the meaning of an outline is just like a table of contents. Yeah, yeah. It just means a table of contents, and then the intro is just kind of that basic intro introduction paragraph. It really doesn't have to be anything, just like a paragraph about what you're going to cover or what you think you're going to cover in your paper. And it can evolve because, I mean, as you write it, you may update your intro because, the next part will be to submit a rough draft of three pages, I believe. And so then you'll put the outline and the summary, the intro, and then the 3 pages, and then you'll finally submit the whole thing, the outline, introduction, and the 6 pages. But yeah, the outline is just a table of contents. Oh, absolutely not. You just choose parts. Yeah, you would definitely write a whole book if you had to cover the whole video. Um, yes. Yeah, exactly. Yeah, because I mean it's a 6 page paper. This video is very lengthy, and so right, having the checkpoints and making it a project, and so that it gets a little better each time. Yeah, makes sense. Yeah, yeah, you could definitely write a whole thesis on networking from that video. It's a really good video. But yeah, basically it's this course compacted into a couple hours, right? I mean, it's a phenomenal video, and so I use it as a good supplement to the course because a lot of people do really well with videos and that, and I used this before we did videos, right? Yeah. Yeah, it's lengthy. Yeah. Uh, but it's a really good video. Right. Yeah, 5 hours exactly. It's almost 6, I believe. I wanted to think that. uh, right. Yeah, I know. That's why this is a project and it's very lengthy, right? Uh, you're in the 30 minutes. Yeah, it's really good. But that's why the outline and introduction is due this week, and then week 7 is the rough draft, and then week 9 is the full page. So that gives you time to digest the video. Um, so absolutely. Right. Yes. Yeah. Sunday. Right. This is due Sunday. The outline and the introduction is due Sunday. Right. Sorry. Yeah. All yeah, are due today. Yeah. I should. I'll change that to this week. That's a good observation. This used to be. Yeah. in the face-to-face classes, I had a due date of when we met. So yeah, now it doesn't apply online. Good catch. Yeah, it is right. There's a little nuances, right? A little learning curve on little things. Yeah. Uh, so that's the video project. So yeah, please don't forget to work on that because it's very lengthy, but you do have some time uh, to get it done. And like I say, it is a good complement to all the course material that we're doing. They cover everything pretty much in a lot of detail too, but it is a lot. Uh, then our networking lab, right? And so you already submitted it. It's a fairly simple packet tracer lab, and so please don't hesitate if you have questions or anything with that. But if you went through the packet tracer course, it should be fairly relatively simple. You're dragging two PCs and a switch to the workspace, and then configuring them and hooking them up. So it's not anything major. And then our chapter questions. So, but because we're also in the summer, uh, I ended up doing that, just messing around. Yeah, it shouldn't be hard to do again. Yeah, exactly. Right, if you took the course, it shouldn't be, that one shouldn't be hard. It's this one that is going to be very hard, but because we cover this in chapters 3 and 4, and this is because we're in summer mode, we're doing that 2 chapters a week. I mean this subnetting is really challenging for a lot of students because it's using binary math a little bit, and so I'll try and go over and cover it. Yeah. You do some netting in the OS classes, or you should, right? Right. But I know when I teach the OS class, my students do have to do subnetting. Uh, because yeah, it is pretty important. But we do it at a much deeper dive here because this is a networking course. Yeah, yeah, you remember the packet. Yeah, exactly. Yeah, so you'll be in good shape because right, I on my OS students, I do a deeper dive than most. So yeah, you'll be in decent shape. Oh, that's good. That's good. Well, this will be a packet tracer lab, and it's very uh, uh, challenging. In fact, I've included the worksheet, so I've included the student version and the instructor version for this because this lab is very challenging, so that you can learn how to subnet easily. Um, yeah, so yeah. Uh, because the workbook is challenging, but it's better to actually do it and see it working, right? Um, and so in this lab, you'll create the packet tracer, and let me go ahead and launch this and show because, like I said, I mean, you have till week 8 to finish this, but it's going to be a challenge. So it's supposed to be as challenging as the packet was. So that's scaring me. Hold on here. Okay. Right. Okay. So here is our network. Um, and let's see here. Right. So then here it comes bin. So for PC01 and router one, you had to subdivide this network into two networks, and then create your sub interfaces and all that. I mean, it's very detailed. Um, so you're, you're creating multiple networks here. Each almost each device is going to be in its own network. So it is very challenging to say the least. And so you've got um, uh, basically one IP address space that you have to assign across these networks and get it all working so that eventually that PC0 can ping, the laptop or the printer over here and vice versa. So it will take a lot of time. I do, let's see here. I wonder. Right. So it's intimidating looking, right? But I guess just looking at one network at a time. Exactly. And so the instructions, let me see if I can get back. How did I lose the instructions? Packet tracer. Right. So we'll be doing things a little bit. So I mean that is one thing. Is as we go through the packet tracer, we'll do parts of these and show you how to do the VLANs and things like that. So I mean it's not that you can do it. It just the you can't do it yet, right? Because you couldn't just come in here, but you need to learn subnetting first. So, and this is why I'm wanting to tell you right now to look at that worksheet, get comfortable with subnetting, and then as we go along, you'll be able to do these, right? Uh, Now it's done exactly right. It's all in here. I guess I could put it outside of it too. I wonder. Yeah, it's a lot. That's why you have almost the whole course, right? It's, uh, all right, so all right, I did get it. So let's go to let's see here. Definitely want to print this right. Let's see here. I'm gonna add this. Uh, I realize we don't have a working printer. No. let me see. This might be too much to be putting in there. We'll see. We'll see how that looks. But so I've put it in here as well. So it's just text right there, and then you can download the instructions, the subnetting doc. So it should be a little bit better. Yeah, that'll be a little easier to work with. Okay, good. Yeah, I agree. That's a lot better to see what's going on, uh, and for each so that it is a lot. Yeah, I'll have to start cleaning this up a little. This is the first semester I'm using this. I was just doing the subnetting workbooks, but apparently the instructor version got leaked out and people were using it, so it wasn't much of a challenge for some. So so I created this subnetting project as a extra credit anyway for my classes, and but this will be the first time I'm using it as the subnetting class. So got to learn a little bit to learn on this one to make sure that it's usable. And then I hate that we're doing it in the summer because you know, it would have been nicer. Usually I spend a lot of time on subnetting over the weeks to build it up because it takes time to grasp. But that's why this project is not due to the week 8. So you have that time. We'll still have the time to gain that. So I would highly recommend that you look at the workbooks. Yeah, it's definitely a lot. Yeah, yeah, and that's just it. It is definitely a lot because subnetting is not an easy concept to grasp. But once you do, it is easy. It's just for a lot of people, it just takes a while to click. But once it does, yeah, yeah, right. Well, we should be covering it, chapters 3, 4, and then chapter 8 too, I believe. Um, but we'll definitely cover it, and I'll cover it more as well. Right? Yeah. The workbook is a great place to start. I mean, it helps you walk through and go through it, and then there's the instructor version, so you can check and see how you're doing. So definitely don't worry. We'll get you there. Okay. Yeah. Exactly. But here, let me go ahead and go through the subnetting. I guess we really probably should, and I know we were going to do some of the questions, but I think this is probably more important to go over uh, than anything else because this will help with a lot of the assignments going forward too. Um, so with our IP addresses, there's this concept of classes, right? Well, and we're talking about IPv4, all right? Um, that's version 4. It's really the IP addressing scheme that's been out for a long time, and we still use it. There is IP version 6 out, and it's starting to get used, but most internal networks still use the V4. Yeah, it's moving to 6 is so expensive to switch over. Right. Well, the equipment wasn't there for the longest time, and well, the biggest thing is, all right, so these are IPv4 addresses, and let me go here and IPv6 address, and let's see if we can. Yeah, here's one. Oh, oh, come on. Okay, so here's an example of an IPv6 address. All right. So it's 128 bits long, right? Uh, yeah, right. Whereas the IPv4 is 4 digits between 0 and 255, right? So um, most companies still use IPv4 internally because it's so much easier for humans to use the IPv4, and then you'll use the IPv6 addresses in conjunction with 4 outside of there. Um, but we do have to, I mean, we do have to eventually start really using 6 because we ran out of IPv4 addresses, public addresses. Now, these private IPs, these 3 sets of IPs right here, everybody uses internal. They're private and they don't go over the internet. And so um, your computer at home is probably using one of the 192.168 addresses. Okay, most likely, most cable providers and internet providers for end users, because you can do 256 computers in this IP space internally. So at home, you're not likely to have over 256 computers and servers or devices, most likely. So assigning you one of these numbers at home, and your home network would have this number assigned to it. Now, you do have the 172.16, the 172.31 networks. There's different networks for it. So there's 16 networks. Yeah, can you imagine having that many at home, right? Yeah. So there's 16 Class B. So the difference is the Class A network uses the first 8 bits or this first digit for the network ID. And it has 3 8 bits or 24 bits for hosts. So there's like, I think it's 4 billion computers and IDs or systems that you can have, over 4 billion that you can have on a Class A network. Class B networks, they use the first 16 bits or the first 2 digits, so 172.16 or 172.31. They're different networks because these first 2 digits are different, and so they use the first 2 digits to recognize the network. Whereas the Class C uses the first 3 or the first 24 bits. So this, this has 256 256 networks with 256 computers available, right? This has 16 networks with 65,535 computers per network, and then this one has 1 network with over 4 billion computers that can be on that. So a lot of organizations will use this and they'll subdivide it and create, and subnetting is the process of taking a larger network and breaking it down into smaller networks, right? Most people, organizations will never need over 4 billion computers on a single network. In fact, a single network of that size probably really wouldn't work very well. I mean, without having a router in between and controlling for broadcasts and stuff like that, it would be a nightmare. So we subnet these larger networks, and we can even subnet these smaller networks too, because in a lot of cases you don't need 256 numbers. So you could subnet that, and you could break each of these into like 2 networks with 128 possible hosts on it, or maybe 4 networks, right? Because at home you could still probably break one of these networks down and give 12, 16 hosts or something like that, and still be okay. But so we have these ideas of classes, and it bases off what number you have. So if the IP starts with the number 1 through 127, it's a Class A network, and that means the first 8 bits of that IP address are the network ID, and the last 24 bits are the host ID, right? The Class B is 128 to 191, and that is the first 16 bits are the network ID, and the last 16 bits are the host ID. And then 192 to 223, the first 24 bits are the network ID, and then the last 8 bits is the host ID. And then we've got the 224 to 239 is reserved for multicast, right? So if you're streaming and doing things like that with videos, that broadcast is possibly using these IP ranges. And then we've got an experimental range, the 240 to 255. And zero is just not used. But we have from 0 to 255. And so the subnet mask, this is just stating the default for a Class A is 255.0.0.0, which is just saying that the first 8 bits, because 2 to the 8th is 256, but since we're 0 based, 0 to 255 is 256, right? So if you have all 8 bits selected, then it's 255, right? So this is just saying the network ID is the first 8 bits. This is saying the network ID is the first 16 bits, and this is saying that the network ID is the first 24 bits. Does that make sense to everyone so far? I know it's a lot. Yeah, okay, good. And so when we subnet, we can borrow bits from the host ID. So in a Class A, we have 24 bits that we could borrow, but we can't borrow all of them because we have to leave some bits for host, right? Because there's no, it's not good to have a network that only has a network ID and no computers, right? It's not a network. So we can borrow probably, I think it's 22 bits and create networks. So for each bit, right, it's a power of 2. So if we borrow 1 bit, we can create 2 networks, right? 0 and 1, right? We can represent 2 networks with a 0 or a 1. So the first network we'd assign 0, and the second network we'd assign 1. If we take 2 bits we can create 4 networks, right? Because 2 to the power of 2 is 4. So, and you'll see that we're just going to be multiples of 2, right? Well, powers of 2. So if we take 3 bits, we can do 8 networks, right? Because 2 to the third power is 8, right? And that's just the number of combinations of zeros and ones that we can do, right? Does that make sense? Okay. Hold on. Can you explain a little? Sure. Sure. Um, so let's look at this here. Let me see if I can. Let me see. Can I blow this up? Yeah. All right. So in this example here, the class A, right, we had 255 as the number, and that's because, and I wish they would have done this, but all these are ones, right? This should all be ones for a class A, and this should be all ones. These 16 should be all ones because they're already taken for the network ID, and these are all ones are used, right? They're taken for the network ID, right? But that leaves all these that say host, right? These are bits. So if we take one of these bits, it can be 0 or 1. So we can create 2 networks or identify 2 networks by that 1 bit if we borrow that bit and make that part of the network. And we're always going to borrow the bits closest to the network. We're always going to borrow the ones on the left, right? So if you take 1, you take this one. If you take 2, you take these 2. If you take 8, you take these 8, right? But each time you take it, you get an option of 2, but it's a power of 2, because if you take this, you can do 2. If you take these 2, you can do 4, because this can be 0, 0, this can be 0, 1, this can be 1, 0, or it can be 1, 1. So you have 4 combinations, right? If you take 3, then you have 8 combinations. You got 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 1, 0, 0, then 1, 0, 1, 1, 1, 0. But you get the idea. You get 8 different combinations so that you can identify networks. So you're basically creating network IDs or numbers, right? So that you can keep track of them. Because basically the idea is you want to create a subnet mask, because you create these so that the computer can do the math and say, oh, that packet is meant for this network, right? And because if you take the network, let's see here. Let's go here. So let's just say we took the 10 dot network, right? It's only one network. These would all be all on the same network, but that wouldn't work. We need to break it up, right? So we could break it up into easily. 1, 2, 3, 4, 5, 6, 6 networks. So we could take 3 bits and create 8 networks, and then this could be a network, this could be a network, this could be a network, right? And so it would make it easy to address these, because think of it as the subnet is creating streets, right? So this one lives on First Street, this is on Second Street, this is on Third Street, this is on Fourth Street. So it's being a way to be able to find it. The network, the subnet is the network, it's the street, whereas the host portion is the actual, I live at 123 First Street, right? So the 123 is the host part. That tells it that's this house, right, or this PC, right? So that's the host part. Whereas the network says I live on this block, right? And what we're doing is we were assigned, a patch of ground, and we're subdividing it like a builder, and we're creating roads in our new subdivision. Does that make sense? Okay. Okay. Great. Cool. So that's the idea of subnetting, is we're taking it and it's just powers of 2, but so you got 2, 4, 8, 16, 32, 64, and then 128. Those are the amount. Each bit that you take, right, is going to multiply up how many subnets or how many roads are you making, how many networks are you making, right, for each bit. So you can see with a Class A, I mean, we have a lot of bits. We can create a massive amount of networks from one Class A address, because we have 24 bits available for hosts. Now, the Class B, there's only 16 bits, but we still can create quite a few hosts. But the Class C, we only have 8 bits. So, if we were able to use them all, we could do 256, but we can't. So, because we have to leave some. But you could still create quite a few networks, but definitely, doing 3 is definitely doable. Creating 8 networks out of a Class C, that would leave. So then what that does is, okay, if I took 3, so that leaves 5, right? So then I've got 2 to the power of 5, right? So 2, 4, 8, 16, 32. So I've got 32 hosts available that are left, but for each of the 8 networks. So I took a network that had 1 network and 256 hosts, and I'm borrowing 3 bits, the first 3 bits, and I'm creating 8 networks, each with 32 hosts, right? Or, well, 32 IPs. Let me be more specific. So, because if you got 8 times 32, why is that doing that? 8 times 32. Okay, my number pad is not working. All right. 8 times 32. It's 256. Well, it's a Mac keyboard. I don't have one. I'm still getting used to my Mac. Yeah. But anyway, so we borrow 3 bits to create 8 networks. That leaves us 5 bits, and so we can have 32 IP addresses on the 8 networks. That gives us 256 total IPs, which is what we had to start with. So we didn't lose any IPs yet. But the thing is we created 8 networks, so we have to be able to identify each of the networks, right? So we actually lose 1 IP address for the network ID. So that can't be assigned to computers. Before, we had 256 IPs, and they could be assigned to computers, except for the last IP. The last IP in any network is used for broadcast. for the network. So that IP, the last IP, can never be used in any network, right? So technically, for a Class C, you have 255 available IPs. If we subnet it into 8 networks, we have to have 8 IPs uh, for each of the networks, and 1 IP for each of the networks for a broadcast. So what we say is you have 32 IPs per network, you lose 2. You always subtract 2, and that's the available amount of hosts. So we could have 8 networks with 30 hosts because we lose 2 IPs per network for broadcast and the network ID. But that's the price or the cost to subnet. You lose 2 IPs for every network you create, because you have to have a IP for the network ID and an IP for the broadcast for that network. But it's an acceptable loss. I mean, you're still doing pretty well. I mean, on 8 networks, you lost 16 addresses to create 8 networks, and then it's much easier to deploy and utilize, because if it's on a network, you have to have a router to talk to each other. So in this scenario, although this gets even more complex, but we'll just go basic. This network, these computers, if these were all on the same network, although in this assignment they won't be, but we'll just say for now, these are all on the same network. They don't need a router to talk to each other. But to talk to any of these other computers, you have to have a router, because to talk network to network, you have to have a router. So even if this was, let's say we broke the 192.168.1 network in 2, right? So the first address, say we'll assign, let me get a, so our network is 192.168. Man, my number lock is not working at all. Might have to switch keyboards. All right, so 192.168.1.0. All right, so that was our network start. And now we're going to, and our subnet mask, 255.255.255.0, right? Because it's a Class C, the first 3 octets or 24 bits are taken for the network. So this 192.168.1, that identifies our network for us. And so this is our subnet mask. But we're gonna just borrow 1 bit, all right? So that makes, and we'll talk about it here in a minute too, but so that makes our subnet mask 128.0, because our network bits, as we pull them off, there's 8 bits. Let me see where, yeah. So there's 8 bits. So this bit here is, we'll just go here. So this last bit here is 2 to the 7th, right? Because we'll go with this. This is 2 to the 0, which is 1. This is 2 to the 2, which is 4. 2 to the 3, which is 8. 2 to the, whoops, 2 to the 3, which is 8. 2 to the 4 is 16. 2 to the 5 is 32. 2 to the 6 is 64. Why did I? 2 to the 0 is 1. 2 to the 2 is 4. 2 to the 3 is 8. 2 to the 4 is 16, 2 to the 5 is 32, 2, oh, right, 64, 128, 256, because we've got, why is that, doesn't work that way. Oh, because it's 1, 1, 2, 4. So, okay, it's not the powers. I'm sorry. It's been a while since I had to explain it this way because I'm used to having a nice chalkboard and doing this a lot easier. So it starts at 128. This is 128. This is 64. This is 32. This is 16. This is 8. This is 4. This is 2, and this is 1. Right. So the largest bit is taken first. Oh, good old Microsoft Paint, right? Yeah. Let's just do Notepad too, but so they go in order, but my number lock is not working. 128. The second bit is 64. The next bit is 32. The next is 16. The next is 8. The next is 4. The next is 2. And then finally 1, but you'll never take that because you can't take the last bit. You got to have it. You really can't take these last 2 because you got to have machines, right? Because if you took all of them, you wouldn't have it. But you could in a class B, but not on a class C. So right, because you can take 9 bits for a class C or class B. But it starts over again, right? Because you have the dot, right? So the numbers end at the dot. So these right here, when you add them up, they equal 255, right? So if you take all the bits, it's 255. So if we were to borrow 8 bits, this would be 255. But we're not 0, it's 128. We're dealing with a SC. So for example, if we had the 172.16.0 network, that's 255.255.0.0. And tab out of VMware for a second. Apple Support says the option that turns off the mouse keys, use system preferences, click accessibility, click pointer control, and then click alternate control methods. Interesting. I'll have to check that. It's that is interesting. All right, so the default subnet mask for a class B is 255, right? If we take one bit from it, then it becomes 255.128.0. But if we take 9 bits, it becomes 255.255.255.128. Oops, one too many 255s. Is that making sense? Because I take the first 8 of that third octet here, and then 1 bit of the 4th octet. So the third becomes 255, and the 4th becomes 128. Yeah. Okay. Good. Right. And so then in here with the 192.168.1.0, right, we start with the default mask of 255, and we have 8 bits left. If we borrow 1, it's 255, 255, 255, 128. If we borrow 2, then it's 192 because we take 128 plus 64, right? And that equals 192. Then if we take 3 bits, it's 224. It's 128 plus 64 plus 32. And then if we take 4 bits, it's 240. It's 128, 64, 32 plus 16. And then if we do 5, it's 248 because now we add these all up. And then 252 if 52 if we're taking 6, right? And then 254, which you probably won't do because if you're taking all of these, that only leaves you 1 bit, and 1 bit is for the network and 1 is for broadcasting. You have no hosts, right? So 252, this 255, 255, 255, 252 is really the minimum viable, right, network, because then you have at least 2 hosts, right? So that's probably the smallest network that you can create that's usable. Yeah, and then most likely that's going to be routers, right? So a good place to use that would be between here, right? Between this router and this router and this router and this router. I mean, there's going to be multiple network cards in these routers, but between these routers, there's just 2 devices. So you could have a network that is set to 255, 255, 252. So anywhere that you have just 2 devices, that'll work. And in fact, I believe, well, maybe not in this one, but in others that you'll have that. But that in general is subnetting, is that practice of taking a network, because this network is 192.168.1.255. So our original network is 192.168.1.0 to 192.168.1.255. This was our original 256 IPs, 0 to 255. Now if we did this and we broke it up, right? If we did all the way down to here, we're taking 1, 2, 3, 4, 5, 6, right? So we have 2, 4, 6, 8, 16, 32 networks with 4 IPs on each. And so our network 1 would be 168.1.0 to 192.168.1.3. And then our second network would be 192.168.1.4, 192.168.1.7, right? And 192.168.1.8. And 192.168.1.11, right? So, and then 12, right? So it just repeats. So these networks, the nice thing is the network IDs go up by 4 because we have 2 bits, right? We can have four IPs, so each network is going up by 4. So what I do is I usually just do all the network IDs because it's so much easier to do it in my head that way, right? One, because you're kind of 4, right, or 8, 16, 32, 64, or 128, right? Depending on what network ID or subnet mask you did, how many bits you're using, right? But since we're using, in this case, we're using all 6 of these, it's going up by 4. And then you just subtract 1 from once you have all of them. And so it's much easier to find out what the broadcast is, right? Because these are the broadcast. These are the broadcast IDs over here. So then the first available IP on this subnet is 1.1, right? The first available on this is 192.168, 1.5, right? And so it's easy to figure out this because, and you'll need to know this because I think in the instructions here, I'll tell you to use, let me see here. Let's see, yeah, you use the last usable IP for the first subnet, right? So I give you subdivide this network into 2 networks, right? So this is a class C network, just like we were doing. So let's do this one, right? So we're taking this class C and we need to break it into 2 networks, and then on the router you would create a sub interface, and we'll go into how you do that and set up for VLAN 5. And virtual VLANs are virtual networks basically on the hardware. And then you put the IP address for this router interface is the last usable IP from the first subnet. So let's go up here. So we want, oh, really? Sorry about this. I think I just repasted this and I didn't get it into my clipboard. Okay. Okay, so copy that. All right, so what we're doing is taking this network, which has a 255, 255, 255.0 subnet mask, and we're going to break this up into 255, 255, 255.128, because we're going to break it into 2 networks. So we just take this first bit, that gives us 0 and 1, so we can create 2 networks. And so then our IP address range for our first network is to 127, right? Because 128, these are our 2 networks, right? So our first network is 0 to 127, and our second network is 128 to 255, right? So then our last usable, so our first usable on the first network, let's do this, is 1, and our last usable is 126. So that's telling us to use the 205.115.5.126 as the IP address for that router. Does that make sense? And we would use this subnet mask, this 255.255.255.128, when we assign it to the router, because that would tell it that, oh, I'm in the first half of the network. All right, I've had you guys here for an hour. Is there anything else that you wanted to cover before? We'll touch base with this, like I said, throughout the semester. But I definitely wanted to make sure we went over subnetting to some degree first. Um, but definitely go through the workbook. It'll give you a lot of practice of doing this, and it'll make a lot more sense when you do it yourself. Yeah, and then yeah, watch this again, and we'll definitely don't like I said, this is not due till week 8, so don't freak out. This takes time, but look at the workbook, go through the workbook, review this video, and and work at it, and you've got plenty of time, and then it should make a lot more sense, and then the assignment will be a lot easier once you get through that. But I also want to make sure that we cover anything else that you had any questions on as well. Still want to go over quizzes after the main part of your lecture. We can do that. I mean, I'm up for that. I just know we've been here for an hour, so I want to be conscious of your time. And this was a big topic, but we can definitely go over the quizzes. All right. Okay, so week 4 quiz chapter 3. Let's just go through here. Let's see how this looks. Okay, that's not too bad. It's fairly readable. All right, so at the transport layer of the OSI, what is used to find and communicate with a particular application running on a host? C. Yes, port numbers. The 1024 to 65,535 range of ports is also known as the well-known range. False, right? It's everything under 1024 is the well-known range. Think of port 80, right? 443, right? For SSL and web traffic, those are the well-known, right? Almost everybody kind of knows those, so they're well-known. A hexadecimal number is a number written in the base 16 number system. False. Right. ICANN is responsible for restrictions on use of the .com, .org, and .net top-level domains. Actually, I believe this one to be true. It's been a while since I dealt with those, but I mean, I do believe it is ICANN. How can you determine the manufacturer of a network card based on the MAC address? C, yeah, the first 24 bits of it's 40 bits, so the first 24 bits identify the manufacturer and usually the actual card type, and then the last 24 bits is the actual card itself. With a fully qualified domain name of ftp1.dallas.mycompany.com, what part is the domain name? C, right, mycompany.com, right. And just as a FYI, like the host name or the actual host name would be the FTP1, right? and then these are like the Dallas is an organizational unit or something like that, depending on what book and who you're talking to. But I would go with organizational unit. Um, Encrypted control of remote computers using the RDP protocol is accomplished using what port? What port number? What port number does RDP use? It's 3389. Yeah. All right. Yeah. 3389 is RDP. 22 is secure shell, SSH. Uh, what type of IPv6 address is the FE80, etc.? Really, you only need the FE80 to know what it is. B, yes, it's a linked local address. On a Linux-based system, what command can be used to display TCP/IP information associated with every interface on the system? Close, right? Oh, Linux. Yeah, sorry. Thank you. Yes, that's exactly it. Yeah, Linux. Windows is A. Linux is C. Well, although they've actually upgraded, but anyway, uh, according to the book, it's C because yeah, they've gotten rid of ifconfig on Linux for IP. But anyway, if a host IP, I know, right? If a host IPv6 address contains the network adapter's MAC address within the last 64 bits of the IPv6 address, what standard is being used? C, right? I do believe I'll admit I'm a little rusty on IPv6, but that is sounding like it's the EUI 64. Lots of C's. Yeah, but don't rely on that. Which of the following IP addresses would be a loopback IP address? So we did not discuss that. Uh, but it is B. Yes, the 127 range, right? It's a class A. For whatever reason, the powers that be said, let's use the 127 class A range for loopback and throw away 4 billion IPs. And then we ran out of IPs, and it's like, well, you threw away over 4 billion of them. Why didn't we use a class C? Yeah, right. But yeah. What statement regarding the 4 million? Sorry, but anyway, still too many. What statement regarding the server message block protocol is accurate? All right, so protocol we use to synchronize block messages between iSCSI drives. It's used on Windows and Unix systems to share files. Yeah, that is it. I'm just trying to make sure there's not a better answer. LDAP, signaling protocols, connection between hosts. Yeah, no, that's it. Good job. You are setting up a DNS zone and have been asked to create SPF and DKIM records. What type of DNS record will hold this information? B, right? Text records, right? Which of the following is not a range of IP addresses recommended for use in the private network? So A, right? That's our lost class A for loopback. In the DNS DNS hierarchy, where is information about how to find the top level domain servers held? C, right, on the DNS root servers. Which of the following IPv6 addresses represents a global unicast address? Got nothing on this one. I believe it is C as well. What command can be used to check a domain computer's time source from a command prompt window? The time source window. Wow. Yeah, I'm going to go with that, but yeah, that one's nothing I've done in years, so or probably ever. Your supervisor has asked you to configure a new prototype network with a dual stack configuration. What does that mean? Uh, D, yeah. IPv6 and 4 will be used. All right, in a DNS zone, what type of record holds the name to address mapping for IPv6? Not sure. It's C. It's the 4A record. The A record will hold the IPv4, and the 4As will hold the IPv6. And what does the MS record do in a forward DNS zone? It's A. So it's a mail exchange or mail. It identifies your email server. So let's see. There were a couple there. Uh, all right. So I did miss one or two. Yeah, I missed two. All right. Hexadecimal is 16. Okay. Yeah. I, and the ICANN is false. Okay. I'll have to for restrictions on use. Huh. All right. I'll have to look at that. Okay. So all the others were so we were right on all the others. Uh, all right. Nice. Yeah. Not too bad. Not too bad. Um, all right. So then let's go. Let's go to chapter 4. All right. What command will list only? Oh, okay. Which command will list only current connections, including IP addresses and port numbers? B. No. It's that's that, and I believe it's -n because of the numbers. Uh, but once again, not a command I've ran in a while. Which trace route command will perform a trace using ICMP echo request instead of UDP datagrams to the host's SRV1 mycompany.com? All right, trace route command, the ICMP. Wow. Yeah. I'm with you. So they're all trace route. Um, I'm going to throw out the A because it's not a switch on there, right? So, um, but yeah. Okay. That would make it D, right? Why do I not have trace route? Okay. All right. So they removed that from there. Okay. Yeah, I'm guessing it's the I. That's where I would go with it, but we'll find out. It'll much it be A, but a routing nation protocol. The only reason I've ever used trace route is just to trace route to there with no parameters. Never had to need it to use ICMP echoes because ICMP echo request is turned off by most firewalls and devices, so you can't use it. uh, yeah. Routing Information Protocol, RIP, is an interior gateway protocol that uses a link state algorithm. False. I do believe you're correct. It's not. It's not an. In, well, it is an interior gateway protocol, but I don't think it's link state. If the VLAN tag is present in an Ethernet frame, what is the maximum frame size? It's present. The 1500, right? I do believe it's 1500 or 1522, but I think it is 1500. You are connected to your network Cisco router and need to verify the route table. What command should you enter? All right, so verify the route table. C, right? Yeah, show IP route. Yeah. IPv4, IPv6 use the same packet format. Yeah, false, right? Which routing protocol started as a Cisco proprietary protocol and combines some of the features of a link state protocol with that of a distance vector protocol? Right. Well, that's D. Right. That is D. That's Cisco's. In a TCP segment, what field indicates how many bytes the sender can issue to a receiver before acknowledgement is received? What field indicates the sender can issue a receive? Right, the sliding window, right? How big of a response can you send? Right, how many bytes can I accept? By default, what is the MTU size on a typical Ethernet network? Right. Actually, I'm thinking this is 1500, and I want to say that this is 1522 because we're adding the VLAN tag. That's we'll find out. But in general, a layer 3 uh, or layer 4 switch is still optimized for fast layer 2 data handling. In general, layer 3 or layer 4 switch is still optimized for fast layer 2 data handling. Yes, that is true. It just does extra routing detail. TCP uses a 4-step process called a 4-way handshake to establish a TCP connection. Syntax, and I think it's a 3-way handshake. It is a handshake, but that's yeah. Synac, yeah, 3. Which of the following is not a task handled by a router? Four. B, right? It does not forward broadcast. That's the whole purpose of the router. Well, one of the main purposes is to block broadcast, so you can separate networks so that the broadcast traffic doesn't overwhelm. Because if we didn't have routers blocking the broadcast, the network would be unusable because we'd have these broadcast storms from every computer on the network in the world. What IPv6 field is similar to? Yeah, it would be yikes. Yeah. What IPv6 field is similar to the time to live field in IPv4? See, no, I believe that's the flow label. Yeah. UDP provides error checking, but not sequencing. That is false, right? UDP is just sends it. Says everything at you, right? Which command will produce statistics about each message transmitted by a host separated according to protocol type? So produce statistics each message received about the host by protocol type. Go with B or D. Yeah, that's a good guess. I'm going to go with B. A TCP dump command can be used to filter out all traffic except SSH traffic. Go with B. Yeah, I'm gonna go with C because it's port 22. So we're gonna dump the port 22, and they like switches and flags. So the path ping utility sends 10 pings per hop by default. We'll go with true, but I've never used path ping, so I would not know. IP is an unreliable connectionless protocol as it does not establish a session to send its packets. It is unreliable. Right, right. It's true. TCP is the one that's controlling it. Right. Yeah. TCP does all the controls and connections. Yeah. IP doesn't care. You have been tasked with the replacement of OSPF with EIGRP throughout your organization, which consists of a mix of Cisco routers and routers from other vendors. What statement is accurate? B, right, it's Cisco proprietary. It's likely not to run on it. Yep. What is the purpose of the checksum TCP field? Pretty well, it's D, right? So it's the checksum. So if you take the packet and you run it through an algorithm, you'll get the checksum, and so you can guarantee that what was sent was what arrived. So that you can tell if it was corrupt during transmission. All right, let's see. There were quite a few on this here, so I'll admit there's some very specific. Yeah, that's what I thought. So we lost 6 of them, which is not good. Um, so, all right, so it's Big I. Big I for trace route. Okay, well, that's good. Yeah, yeah. I saw the little I and I didn't go down. So, uh, but yeah, and so it is false, right? So I didn't think RIP was a link state. Uh, and so yeah, so that's good. I'm glad. Oh, oh, none given. I thought we put false. Anyway, it is false. Um, so that makes me feel better. Um, yeah. So yeah, the MTU size was 1500, and it was 1522 if the VLAN tag was on. That's what I thought. Um, so that's good. Let's see here. Flow label. Oh, the hop limit. Okay. Yeah. I'll admit, IPv6, I never had a chance to really use it because we made IPv4 work forever, and I never had to use IPv6 at work at all. Never did. So I'm still learning it. Yeah, yeah. I'm very up on 4, but it's dash S. All right. Yeah, we had a 50-50 shot, but it's nets. I knew it was net stat. You know, um, that's why I hate these type of questions because I don't memorize if I don't use it. If I don't use it all that much, right? Um, that's that, right? And then so this one, of course, this was one of those, slash question. And I pull up the manual. I figure out what it needs. If I need what it does, why would I memorize what it does? I can get it. And if I use it that often, then I'll know it. But yeah, um, I got more important things than memorize which switch. Yeah. Oh, so you were right. It was a TCP dump fort. That's very odd that it's not a switch. Uh, but all right, that's a very rare uh, occurrence. Normally, it's a switch. And yeah, path ping. Yeah, like I told you, I had no idea. But so path ping does not send 10. I'm not sure how many it does, but normal ping does 4, but I have never used this path ping utility. All right, so we did pretty good, yeah. But so path ping, just remember it's not 10, and TCP dump 420. Like I said, these questions I just don't agree with too much. Any of these netstat questions where you're memorizing switches. Uh, yeah, yeah, they're a real pain, right? For one, they're a real pain, and two, if you're actually using them all the time, you'll know the switches, and if you don't, you're just going to look it up at the command line because you're at the command line. That's the power of the command line is you can ask the question. You know, um, yeah. So, but still, we did pretty good. Other than the one question apparently didn't click. Yeah, yeah, the resources is there, right? Exactly. It's just one of those things I never memorized a lot of those stuff because I had way more other things to put in my mind. And but I mean, like I said, the certain stuff you do over and over, yeah, you do remember it, because you do it over and over. Uh, but yeah, but yeah, so it's not too bad. I mean, but for this, especially if you're, if those are going on for the Network Plus and things like that, then you do definitely need to know these things because they test on them. But once again, I don't agree with that type of testing because it you know, yeah. Anyway, some of these things, definitely it is good to know that the numbers, and bytes and sizes because those can make a difference. Things like that. Um, again, there's a lot of commands in this chapter. I will give you that. It's going to be a hard chapter. All right. Well, then I think I've got everything. Is there anything else you would like to cover? Yes. All right. Yes. Have a great day. Thank you. All right. Well, we'll see you next week. And if you have any questions or anything, please, feel free to reach out to me. I am available. Yeah. Oh, you're very welcome. Yeah. What's the best email? Either of the emails at the school, Jeffrey.Spicer at tcc.edu or Jeffrey.Spicer at my.tccd.edu. Either one works. I have the my TCC forward to my TCC, so I'll get it. Yeah. Yep. You're welcome. Yeah. Have a great afternoon. All right, let's stop the recording.